the language is not perfect, but every change to the language carries a heavy cost. So when you want to come and argue for why the language should be changed, and we see that a lot. I'd say that there's probably one a day suggestion for some way to change the Go language. Don't just talk about how it makes the language better, but also spend some time to talk about how it makes the language worse.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean, Droplets, Managed Kubernetes, Managed Databases, Spaces, Object Storage, Volume Block Storage, Advanced Networking like Virtual Private Clouds and Cloud Firewalls, developer tooling like the robust API and CLI to make sure you can interact with your infrastructure the way you want to. DigitalOcean is designed for developers and built for businesses. Join over 150,000 businesses that develop, manage, and scale their applications with DigitalOcean. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. If this is your first time listening, make sure you subscribe to the podcast at changelog.com/GoTime. There you'll find ways to sub via email, RSS, Apple Podcasts, Spotify, whatever's your pleasure. Also follow us on Twitter for live show notifications, clips, and highlights from past episodes, and a whole lot more. We are at GoTime FM. Okay, let's talk generics. Here we go.
Welcome, everybody, to this edition of Go Time. We have a very special episode for you today, the latest on generics. Here with us are Robert Griesemer and Ian Lance-Taylor of Google's Go team. Good afternoon.
Hello, everybody.
And also with us are our hosts with the mosts, Johnny Borsico.
Hello.
And John Calhoun.
Hey.
And I will be running point today. I am Carmen Ando. And welcome again to Go Time. So I guess let's start with the updates. So we had Ian on here, I think it was about last October, and discussing what was then the GopherCon presentation given on templates. And since then, a new draft proposal has come out. So maybe you can talk a little bit about what that update is, Ian?
Sure. So Robert and I released the updated design draft for moving forward with generics. The biggest change was that we dropped the idea of contracts and just decided that instead of having a separate syntactic construct, which was a contract, that we could just use interface types to describe the contract between the type argument and the type parameter. A lot of people looking at contracts had seen that they seemed a lot like interfaces, and people had trouble sort of separating out exactly when you would use a contract and when you would use an interface. So we simplified this, and this was, I should add, almost entirely due to Robert. We simplified this to just use interface types. And then the second big step we made was we've released a translation tool and a type checker. So we have a type checker that works for the design draft, the description of generics in the design draft. So that gives us, some confidence that what we have written about can actually work. And we have a translation tool which translates code into ordinary Go. The translation tool is not by any means a final thing. There's cases it doesn't handle. It's just an experimental tool, but it lets people actually write code that can actually run using generics. So we can get a feel for whether generics actually works for people and whether it actually addresses the issues that they have.
Can you talk a little bit about what your understanding is based on the feedback so far of what people's issues are when it comes to either lack of generics or this current draft proposal?
Well, a lot of the feedback has actually been about the syntax, which is sort of simultaneously the least interesting and the most accessible part of the proposal. Obviously, it's really important to have a good syntax, and we're really paying attention to the feedback that people have given. We actually now have 2 possible syntaxes implemented in the translation tool, which Robert did. And beyond that, there's the semantics, of course. And I think the feedback on the semantics has been quite positive so far. People have tried out generics. They've written some pretty extensive pieces of code. And I think the feedback we've gotten there have been uniformly positive. Robert, do you remember any sort of real concerns at this point?
No, I think most of the feedback was really based on syntactic issues, and we tried to address this with this alternative that we have now, and we need to play with this a little bit more. And then on the semantic side, of course, there's not everything ironed out quite yet, and we have even mentioned that in the design draft, especially when it comes to type lists and exactly what does it mean to have, for instance, type parameters in the type list and things like that. And so we are in the midst of sort of refining that, but I don't recall offhand right now that this was a primary sticking point with feedback from the people.
Yeah, no, I don't think it is. We're trying to sort of really pin down the real semantics of type lists, as Robert said, but we haven't had much feedback. There's been some people wondering about the exact details of embedding a type parameter inside a struct or an interface, which we need to decide precisely what it means, but it's going to affect almost no one in terms of actually using generics in practice.
Speaking of semantics, one of the things that you did in order to inform this new draft proposal version is team up with type theory experts, including Philip Wadler, and you came out with a paper called Featherweight Go, which I don't understand a word of. And I actually am giving a bounty to the entire Go community for anyone who wants to try to demystify that. I know that there is a panel that you were on with Philip trying to talk about that paper and pairing up with that, but maybe you can try to demystify Featherweight Go, maybe in its essence for our listeners right now. Do either of you want to try to take a stab at that?
I can try, maybe not a real step, but maybe a little explanation. So this cooperation, I should say, happened because Rob Pike actually reached out to Phil Wadler, and they knew each other from way back, and Phil Wadler was interested, and then we started talking with Phil Wadler, with Rob Pike. He didn't really have time to participate in this, but then, Phil Wadler, Ian Taylor, and I started talking about what we want to do. And they have, of course, a strong background in type theory. Phil Wadler has done this, not the same work, of course, but similar work many, many years ago for Java. And so he's really an expert. And so now we have a whole team, it's not just him, that have been working on this featherweight generic Go, which is based on Go, but very, very much slimmed down. So we now have a language that really only has type declarations and methods. And those type declarations are only interfaces and only structs. And the only thing you can have is methods and interfaces, of course, and methods associated with structs. And inside those methods, you can only have basically single functional expressions. So it's a very, very simplified language. But what you can do is you can invoke a method. And in this paper, he explores 2 situations. This featherweight Go, which is like the basic Go, simplified Go without any generics, and then the featherweight generic Go, which is that basic simplified Go extended with generic features. And those generic features are very much modeled along the draft design, with the exception of type lists. So there's type parameters, as in the draft design. The type parameters have what in the paper is called type bounds. We call them now constraints, and they're interfaces. There are also interfaces in the paper, and they basically model, in a very, very simplified fashion what the design draft is trying to do with real Go. And the goal of this paper is to prove, first of all, that this is a sensible design, in the sense that the type system that we're creating here is sound. You cannot create situations where you could write a program that would be unsound in terms of the type system. And then also they try to prove and have proven that it is possible to translate such a simplified generic Go program into a regular Go program through a process which is called monomorphization, basically expanding everything for every possible instantiation of these generic functions and types. And then they proved that, these programs are basically equivalent. So that's kind of the gist of this paper. And this gives us very strong confidence that we're not designing somewhere into the blue, and B, that what we're designing actually makes sense from a type system point of view. We're not going to hopefully find problems down the road where we have some, internal inconsistency. So I think that's really the benefit. And I think it really helped us also understand a little bit better what it means to have interfaces as constraints and how we need to, type check this. So I think there is a real synergy here.
Very cool. And would you say because of the partnership, it helped you understand some of the semantics better in terms of how it informed the newest draft proposal?
Oh, absolutely. I think we had part of a prototype working before, this paper was complete. And in the process, there's, of course, all kinds of questions. And what we sort of invented ad hoc, they basically did in parallel, independently. And then when we started talking to each other, especially when we went through the individual steps of the paper, we could basically verify that our thinking was matching their thinking and vice versa. So our ad hoc sort of design that was maybe more based on what seemed to be the right thing to do and not so much driven by a mathematical background matches. And so that's great. So that means we're not doing something weird. Phil Wadler actually took the time himself to walk us through the paper in detail. And this is how, our understanding of the paper came about. I'm not a type theory person. And so I now feel like, okay, I have some sort of idea how to read the math, but I wouldn't claim.
I should add that, my name is on the paper, but I have no claim to understanding the paper at all.
Okay. All right. You've heard it here, folks, that it's not just you. Even Ian and Robert, had a really hard time with the featherweight Go paper and all that math notation. This is funny.
Let me add that they really helped us with the move away from contracts and toward interface types. They pushed us in that direction, as Robert did as well. And so it helped make clear that it would be equally powerful and that it would be usable.
It's worth noting that there is a YouTube video of Phil actually walking through portions of this as well. And I attempted to read the paper. I couldn't get very far, but I did watch the video, and he did an excellent job of sort of walking through some of the key concepts there. I believe there is a plan for sort of expanding on the ideas of featherweight Go. And I believe there's a bentaweight and some other implementations coming down the road as well. These things I imagine, are sort of going to build on sort of foundation you have now to sort of try and figure out, okay, what else haven't we thought of, right, with regards to generics and Go. Is that correct?
Yeah, that's exactly right. They're going to try to add, as Robert said, featherweight Go really is very, very limited. So they're going to try to add other features of Go in and make sure that it's still, this type system is still sound and the generic system is still sound. Which we think it will be, but it will be very interesting to see what they come up with.
Something you mentioned earlier was that some of the feedback was somewhat superficial in terms of limited really only to sort of the syntax. Obviously, there's a lot more under the hood that really must be solved in order to really have a sort of consistent implementation. But to do that some justice, you have folks that are sort of familiar with the common utilization of angled brackets, right, as sort of the way of specifying the generic types and whatnot. And people are scratching their heads. Well, like why? First it was parentheses. Now they're thinking about square brackets. Why can't we just do angle brackets? What's the problem, right? So maybe if you can just kind of explain sort of the dangers, right, of trying to put that into Go right now. Maybe that address some of those early feedback.
So Robert had a really good example in the email he sent out about square brackets, showing a case where you really can't parse angle brackets if you don't know whether you're looking at a generic function or type or whether you're looking at a pair of expressions that happen to have a comma in the middle because it's some kind of multiple assignment. So it's just, that's just sort of a fundamentally ambiguous syntax. Robert, do you want to talk about the importance of parsing without type checking?
Sure. So, even in existing Go, we have some situations where we do not know at parse time what we have. Like the classical example is if you have a conversion or a function call with exactly one argument. So if you say f of x, is this a function call or is it a conversion? We do not know at parse time, but it doesn't matter because we can build the syntax tree at parse time. That's the only thing that matters. And that syntax tree that has a functor, or, maybe it's a type in a conversion and a list of arguments. That's all we need. And that's the same for a function call or a type conversion. And then at type checking time, we can look at this functor and see, is it a type? Well, then it must be a type conversion. Or if it's a function, then, well, it must be a function call. So that's all jolly. The problem with the angle brackets is that at parse time, you cannot even know how to create the syntax tree in this specific case, especially in this example that we've given in the mail. We don't know how to parse this, so we don't know how to build a syntax tree, and that means there's just no way forward to resolve this. One way to go forward would be if we had type information at parse time. And in languages such as C++, where they use angle brackets for templates, there is symbol information at parse time, and the parser needs that to make the right decision. But that also means that everything that you will use at the particular place needs to be already declared at that point. And so in C++, you need to make sure that everything that you're using in an expression has been declared before, some way or another, maybe with a forward declaration of sorts. In Go, we cannot do this because, well, we could, but we don't have forward declarations in Go, and we don't want them. In the very, 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 very first version of Go that's never seen the day of light, there was actually forward declarations, but we got rid of them pretty quickly. In Go, you can have a package that is spanning multiple files, and so if you refer to a function in one file, that function may not even be declared yet. It may show up at the very end of the last file that the parser is going to see. So there's just no way to have this information available. And so without that information, it's just not parsable. And there's no way around it. And so angle brackets as it is right now, it cannot work. So it's not like we don't want to do it or we don't like them. It's just it cannot work with the Go as it is right now.
Changelog News is the best way to keep up with the fast-moving software world. We track, log, and contextualize the coolest projects, the best practices, and the biggest stories each and every week. Make changelog.com your daily destination, or hit the snooze button and subscribe to our weekly newsletter that hits inboxes on Sunday mornings. Join more than 15,000 enthusiastic readers. It'll cost you exactly $0, and you can subscribe right now at changelog.com/weekly.
So the email that Robert is referring to is rather a discussion thread on Golang Nuts, and it is one of the most recent, and it's an addendum to the draft proposal where syntax feedback had been received and a new addition was adding parentheses. So now it's a case of getting feedback from the community about whether the preference is for square brackets versus parentheses. Robert or Ian, what are some of the trade-offs for either or of these in your minds?
So I'd say that the advantage of parentheses, I think, is that type parameters really are parameters, and type arguments really are arguments. And so it makes sense to use a syntax for type parameters that's similar to the syntax for regular non-type parameters. And in the Go, that current syntax is parentheses, so it makes sense to use parentheses. And I find the result to be, it sort of feels natural to me, at least, and it reads well. So the disadvantage is in a complex generic function, you can have lots of parentheses flying around. You can have a You can have type parameters, you can have regular parameters, you can have result parameters. They're all parenthesized lists. It can get a little hard to see exactly what's going on. Also, in a call, at the call site, sometimes you pass type arguments, sometimes you don't. And it can be a little unclear, again, exactly what's going on. Like if you had a new function, the new function might take a type, and then you'd have to have another set of parentheses for regular parameters. And so there's some potential confusion there. There's also, we've discovered certain ambiguities with parsing when using parentheses. Not common cases, but cases that do arise in real code. There were cases where it was ambiguous when you referred to an instantiated type or an instantiated function, and it was hard to know exactly what was going on. Like a simple example would be an embedded field inside a struct. You can embed an instantiated type in a struct. It's not really clear whether you're embedding a type in a struct or whether you're doing some other kind of operation there. So square brackets, by comparison, there's still a list syntax. So now type parameters and parameters don't look the same, which for many people is an advantage. But for some people it's a disadvantage. And then there's seem to be, at least so far, fewer parsing ambiguities when using square brackets. And I don't have a good feel right now for sort of the sentiment of the broader Go community. There are definitely people who like parentheses and definitely people who like square brackets. I don't have a clear sense as to one clearly being better than the other, but I have seen a lot of people saying that either could work, that they don't have any big objections. Do you have anything to add, Robert?
No, I think that's an accurate description. I think we can confidently say that the square brackets don't have the ambiguities at this point that we've seen with the parentheses. And we did not know this in the beginning. We only found out after writing that code where we ran into problems. But we decided to stick with the parentheses because we wanted to make progress on all the other fronts. And the reason for this alternative now is that we revisiting this decision so we can make sure that at the end we have looked at all the alternatives.
So anecdotally, from what I've seen in the Twitterverse and the feeds and all these things, I think there's a penchant towards the square brackets. From what I hear, most think it's more readily apparent what is going on when you look at the code. You don't have to sort of do a double take. Okay, what's applying to the parentheses here, and like you can more easily, very quickly sort of figure out, okay, this has to do with the generic type and everything else is what I would expect. So basically that's my 2 cents there from what I'm seeing from the feedback from the community so far.
Great, thanks.
So I do have one question on that. Have you guys talked with developers of like IDEs or like syntax highlighting type tools that people use to see if any of them have feedback on this sort of thing? Like an example is JetBrains, since they have Golang. I assume that maybe they'd have some feedback on which one is easier to sort of make obvious inside the editor where people are actually coding. So have you had a chance to talk to people who are developing tools like that to get their feedback?
Well, we have talked to the people who developed the Go Please language plugin. And from their point of view, I don't think it matters that much because they're just hooking into the parser, and the parser does support both cases, and the parser is just going to feed back to them what the code looks like. And so they didn't have much trouble adding parentheses support, and they've just recently added square bracket support to Go Please as an experimental thing. So I think at least at that level hasn't been a problem. We haven't talked to JetBrains, though. That's a good idea.
So more practically for the Go community, when do you think that you're going to get enough feedback to move forward with moving from a draft proposal to actually putting it forth as a proposal to change in the language?
Yeah, we don't have any timelines in mind, I'd say. As we mentioned earlier, we're still trying to pin down some of the precise semantics, which I don't think is going to affect any existing code. In fact, I'm sure it's not going to affect any existing code. We want to make sure that we understand it. We want to make sure that, the multiple Go compilers will all implement the same thing. We're going to have some sense of how to add to the language spec. So those are the steps we're looking at now. I mean, we're certainly going to move forward as fast as we can toward making a formal proposal. Of course, at that time, none of it will be a surprise. People will have seen all of the ideas already, and we'll just have to see how it flies. So far, I feel like the reaction's been largely positive, which is encouraging. But I don't know exactly what the timeline is going to be.
What kinds of feedback at this point are you, Robert and Ian, looking for?
Oh, I think we want to see things that don't work, and that you would expect to work. And we definitely have seen some of these things, which tended to be just bugs in our prototype. And we have spent some time fixing those bugs, and we have slowed down a little bit on that because it's just a prototype. And at some point, you have to make a call as to how much time you want to spend on that and making progress elsewhere. But yeah, generally, I think we would like to know, can you write the kind of generic code that you expect to be writing with this design? And if not, why not? Let us know. Is there things that you expect to be working, but they don't? And, are they fundamental to our design? And if so, is there something we need to do? These are kind of the, I think, important questions that we should try to answer ASAP, because once we have something more firm, it's going to be very hard to make these changes later, if not impossible.
Yeah, I totally agree. And I'd say, is there anything you find surprising? If you're looking at code that's written using generics and you read that code, is there anything that you just say I don't get it, or it just doesn't act the way I expected it to act? That kind of feedback would be extremely useful.
Were there any specifics that you guys wanted to avoid supporting? Do other languages have something in generics that you looked at and decided this isn't something we want to support? Or, maybe it's just a really obscure use case or something.
Well, my favorite example is that C++ templates are in fact a Turing-complete language in and of themselves, which is really cool. And we decided we absolutely did not want to support that in any way whatsoever.
And one of the things that I thought I happen to know about both of you is that you have extensive experience in generics coming from other languages. So, Ian, you were on the C++ readability team at Google when you famously saw a spec for the Go language and wrote a compiler for it, I think. And Robert, you were on the V8 team that was writing VM for Java. So are there any things from those lenses of experience where you kind of want to make sure you prevent? And I'm specifically trying to get the angle here of the naysayers who say generics are going to add complexity to the language. What is your experience about keeping that complexity at bay in this proposal?
So just to clarify, I was working on V8 in the very beginning for maybe barely a year. I didn't really do anything with generics in V8. So, I was on the implementation side. My experience with generics was maybe C++ with templates. And probably the highest point there was when I was able to, as Ian alluded to before, it's Turing complete. I was able to write a program using C++ templates that would decide whether a constant was a prime number or not. And the compiler would decide it at compile time. So that's not the kind of thing we would like to support. With respect to, what I'd like to see or not see is, honestly, I'm worried about the kind of code that people are going to write. I mean, there's no question about that. And we see some of the examples that people send us that cause crashes in the prototype, and they're just unbelievably convoluted and really, really hard to decipher. But as other people have pointed out, those people are really pushing the envelope. They're trying to just see, what can I do with this thing? And I hope this is not going to be, the kind of code that people are going to write down the road. I think one of the first things we need to do, if we have this for real, we need to come up with a kind of best practices guide that guides everybody a little bit as to how you should use generics and when you should use them and when you should not use them. Very similar to what we developed for Go routines and channels. In the early days of Go, everybody was using Go routines and channels for everything. And it took a little while for us to learn where it was appropriate and where it wasn't.
I agree completely. And I'll add that I think that one of the things we've been really focusing on during this whole multi-year process is to avoid the complexity that exists in C++ and to a somewhat lesser extent in Java, because those languages are very powerful. And at the same time, they can lead to code that people find difficult to understand. And that's just not a good fit for Go. I mean, and partly it's because they are languages that are much more object-oriented than Go is, that have inheritance built into the language, and therefore they have to reflect inheritance in their implementation of generics, which then leads to considerable complexity in understanding, how do you choose the exact type that's going to be used to instantiate this C++ template. And then they also have overloading, so you have to do overload resolution. These are all really powerful techniques that let people write quite compact code that can be extremely effective. But at the same time, novices come in and they just don't understand exactly which type is going to be used. So we wanted to make sure that we avoided that as much as possible. We wanted to be very clear exactly how a generic function or type was going to be instantiated, what the type arguments were going to be.
It's just like in the, we saw with the Go routines and the overuse, and the channels for everything. I mean, it was kind of crazy there in the beginning, but I'm like, right now you are going to see that surge. There is going to be that spike where everybody wants to use generics for everything under the sun. And then, we're going to start sort of walking that back and sort of developing the best practices. I'd definitely like to see some leadership from the Go team on that. Maybe, an expansion of effective Go, right, on the Go blog and adding some of the ways to sort of caution, right, to provide along with that says, hey, this is really the best use for this and whatnot. So, and obviously, I think a lot of the community members are probably going to be stepping up and writing blog posts and sort of showing, the do's and don'ts, that kind of thing. So it definitely not all on the shoulders of the Go team, but it is something that I think it is to be expected. Like any new toy, everybody's going to try and abuse it, but it's all in the spirit of implementation, right? I think we are going to sort of develop best practices around what should your generic code look like for production system, right? For when you're the one who steps away from it and somebody else has to step in and take it and understand and read what is going on, right? I think that's something that is going to come, I hope.
Yeah.
Yeah, I think one of the things that I really like about the Go culture is that we have managed complexity, our idioms, through the culture, right? We have absorbed the values of simplicity and that we can continue to do so for generic Go. And I think that will be a big part in whether we keep complexity at bay. Is not necessarily the technical enforcement, but the idiomatic / cultural enforcement. And we've talked about idioms as culture on this show before. And so it's kind of interesting to see it play out with generics. So one of the questions that we had was a forward-looking question. And it's assuming that this is going to be a proposal that gets ratified and put into the language. Are there any plans for managing the surge of feature requests for the standard library now that generic data structures and algorithms are possible? Are you going to let that happen in the ecosystem?
That's a great question. Are there any plans? I'd say no, there are not at this point any plans, but there will be plans. The experimental translation tool does come with a tiny little set of sample libraries. And so when I wrote those, I viewed those as kind of prototypes for what we might want to add to the standard library going forward. I don't think they're great examples or anything, but I think that they can sort of show areas where we might want to add new standard library packages and show, possible implementations subject to people really looking at them and making sure they make sense. I don't expect there to be a lot of additions to the existing standard library packages. There might be a few. But most of the existing standard library packages were written without generics, and they work fine. And so, yeah, there may be a lot of people saying, let's add generics here. But, the truth is they work already, and we don't need to add generics there. I think it's more going to be a matter of adding some new packages to really take advantage of generics. Like the translation tool, for example, has a slices package, which has various slices, functions that operate on slices of any types. And it has a chans package that operate on channels of any type. This is the kind of code which we aren't able to write with Go today, but we are able to write with generics. And so I feel like that's going to be where we're going to add to the standard library. We're not going to be moving fast on any of this for sure. But you're right that we should develop some kind of framework for how we're going to add packages.
Practical AI is a weekly podcast that's making artificial intelligence practical, productive, and accessible to everyone. If the world of AI affects your daily life, this show is for you. From the practitioner wanting to keep up with the latest tools and trends,
Spacie is really a library that lets you put together a whole NLP pipeline of the different things you might want to do and extract from your text. You're not just interested in predicting one thing. You might want to read in your text. You want to find the individual sentences. You want to find out which concepts are mentioned in the text, like which person names, organizations, dates. And then you also maybe want to predict something about like what's in the text.
To the AI curious, trying to understand the concepts at play and their implications on our lives.
Would you rather be spending your time improving your blue score by 0.1 on French to English? Or would you rather have a breakthrough on kind of that under-resourced language that, by the way, has 350 million people using it in underprivileged areas around the world?
Here's your expert hosts.
My name is Chris Benson. I am a principal AI strategist at Lockheed Martin, and with me, as always, is Daniel Whitenack, a data scientist with SIL International. Hey, how's it going today, Daniel?
Please listen to a recent episode and subscribe today. We'd love to have you as a listener.
So one of our listeners in the Slack had asked, while you're collecting feedback, is there a good time or like a good expectation for measuring how build speed changes over time? Especially now that things are experimental, I assume that it's not really fair to assume that that's exactly how things are going to be whenever it actually ships. So what should people expect, and when's the right time to give feedback on that?
Okay, that's a great question. Yeah, the experimental tool has no similarity whatsoever to any real implementation. So we know it's slow, and it's going to be slow, and that's just inevitable. If this does move forward to become a proposal and it gets accepted, then most likely the implementation will be to start with a branch of the main Go toolchain, and we'll start adding generic support on that branch, which will involve changing the compiler mainly. And any other changes to other tools that are required. And so that'll be the time to start giving feedback about changes to build speed. We've talked about it with some of the compiler developers, like Keith Randall especially, and we think we can do it without a significant increase in build speed. I mean, there will be some increase in build speed. We don't think it's going to be a huge increase, but this is really speculative at this point. So the time to give that feedback is when we're able to start doing development, and hopefully people will also be able to contribute work when we start doing that work on the public branch.
We can ask other questions there on the Slack channel. When generics are released, would it be released together with the idea of best practices? What they call it here is a standardized collections interfaces to avoid fragmentation. Or do you think this will not be a problem, for example, size versus count versus length? It's a little hard for me to visualize exactly what a standard collection interface will look like in terms of Go. Clearly it exists in C++, and maybe we can just borrow what they do. I'm not quite sure exactly how that's going to work. That is, certain things are pretty straightforward. I think iteration is the more complicated one. C++, in part because of the sophistication of the template capabilities, is able to have a generic iteration interface that works for any collection, and I'm not sure that we're there yet with our less powerful and less complex. On the other hand, I don't know that anyone's really looked at it in the detail, so maybe we can make some progress in that area.
I mean, there's also a difference in the sense that, in Go we already have, for instance, maps, which of course is not the whole collection hierarchy, but it's a significant chunk which doesn't exist in C++. And so there is a temptation there to build this very complete hierarchy, while in Go, in many cases, we just use a map for various things, and that works fine. And the map is in some sense generic already. But of course, that's not to say that this would replace a more comprehensive package, perhaps.
It's a good question, though.
I think it's going to be interesting to see what people will do with this. The design, we try to make it as orthogonal as possible to the rest of the language. And so that really means adding generic type parameter somewhere adds a new dimension to the kind of programs you can write. So it really opens up an entire new dimension of possibilities, and it'll be very interesting to see what people do with this.
One other comment from the Slack is a technological guardrail, if you will. So for the language, currently GoVet and GoLint function as sanity checks that we depend on. What is your opinion on adding new checks added to discourage the use of generic code in this tool chain if all you need is a non-generic version?
Well, we can easily make the compiler, 2 times slower for each additional type parameter. That would limit the complexity quite quickly.
It's really going to have to probably be enforced through culture, right? Or this best practices and idioms.
It's quite easy to see that programs have 1 or 2 type parameters and functions. But if it goes over 2 or 3, then you are starting to wonder, what's happening here? Is this really necessary, or is this really good? So I would say there's some immediate questions right there when you look at code like that. But I'm shooting from the hip here, so I'm just guessing here. And I suspect that there may be things we can say, this is not good. And maybe such things can go into a vet check eventually, but I don't know what that would be at this point.
I suspect things like the Go proverbs will sort of help on this front, just because we have the ones like a little copying is better than a little dependency, I think is one of them.
Mm-hmm.
And I think if people stick with that mindset of copying an entire type, like if you're only using 2 different versions of it, or an entire function or whatever it happens to be, is better than writing the generic version for just 2 different types. But if you do find yourself in a situation where you need to use it for 6 or 7 different types, then generics might actually be the right solution.
Mm-hmm.
The rule of 3 still applies here. I think we've discussed this previously on the show. Usually I don't even start to think about sort of abstracting away or making a generic version of anything until I've seen at least 3 sort of instances of it, if you will. Then I start to say, okay, well, I'm starting to see the edges here. I'm starting to see sort of what is the likelihood of this thing sort of being used in the future, right? Because any code you write, again, we write the code just once, but we have to maintain that code possibly indefinitely. So it's the same rule around sort of those decisions we're making today, asking ourselves these kinds of questions. I think it's just the same things really should apply here. But again, you are going to see folks who are sort of anti-generics. I think in our community, I'd say it's like a 50-50 split. We have people who love Go because of the lack of generics, which is a very specific reason to love a language, but hey. But then you have others who are like, hey, if Go had generics, I would be using it, right? So it's kind of an odd mix. But again, I think it's going to be up to the community as a whole to come up with what are the idiomatic ways really we want to treat generics.
I think those would be nice too, because if we have a concrete implementation to point to, even if you just copy it to the docs, like for the comment, and say like this is a generic implementation of this concrete thing, I think anybody who's unfamiliar with generics or, a little bit newer to programming could look at that and have a much better chance of understanding the code.
One of the things I think about for generics, if this does get put into the language, is whether or not it's going to bring on what I would call the would-be gophers, right? Right now we have the diehard gophers, people who love Go and use Go and maybe have internalized the no generic philosophy of Go. And having generics or implementing generics into the language successfully may bring new gophers to the table. And those new gophers are going to be your .NET and your C++ and your Java gophers. So Robert and Ian, do you have any thoughts or suggestions on how to help them keep Go while also giving them this tool that they've leaned on so heavily on coming from their other language?
Yeah, I hope they will be able to carry their programming practices over where those practices make sense. I mean, where they make sense for Go, I should say. I can't tell whether adding generics to Go will make it that much more appealing to C++ or Java programmers. I mean, I certainly hope it will. But whether it really will in practice, it's just hard to know. I mean, it's still going to be a different language, of course. Certainly, there have been people in the past who've just rejected Go outright because it doesn't have generics. But I don't think there have been that many people who take that point of view. And I hope that those people will take another look when generics comes out. But, from my point of view, I want Go to be open to everyone. I want, all these people to find Go to be a productive language. But it's not really a matter of holding people from the other language communities. I think generics is interesting mostly because, as Robert said, it's orthogonal. It lets us write code that we couldn't write before in Go. It lets us write code that's solves problems in a way that we couldn't really solve before, at least not without going through type reflection or other more, or massive copying or whatever. So it'd be great to help more people. I hope that more people keep writing Go, but I think our main interest is to give people another powerful programming tool, at least my main interest.
Yeah, I'd add on that again, this is not, Go is not now becoming the generic language. It's just yet another mechanism in the language, like we have, interfaces, we have methods, and doesn't mean Go isn't, now you have to write everything in an object-oriented style. Go has always been multi-paradigm. We enable different ways of programming, and we encourage people to choose the right approach for the problem at hand. And so in a situation where a generic approach might be the right approach, then by all means go for it. And if it's not, then, don't do it. And of course, there's going to be people that, really like the playing with types, and more so maybe than getting the code to just do what it's supposed to do. And so for them, it's of course appealing to have this new mechanism. But again, if your goal is to get something done at the end of the day, use the mechanism, the tool that fits your needs and solves the problem the best way.
So along those lines, that's actually a good segue for the segment of the show where we talk about unpopular opinions.
I actually think you should probably leave.
So what I'd like to do is ask each one of you to spill onto the mic your unpopular opinion. It could be related to what we've been talking about around generics, or it could be something that you're seeing out there that perhaps you have a different opinion from.
Or if it helps, some people have just told us they think buses are more efficient than other forms of transportation in New York City. So it can literally be anything.
Well, let me start on that. So I cannot opine on, the buses in New York City. I'm a big fan of public transportation, even though this is perhaps not the right time to advocate for them for other reasons. But unpopular opinions. I don't know if it's an unpopular opinion, but, I like short identifiers. I do. And I feel like the closer they are to where you use them, the shorter they can be. And the further away they are from where you use them, the longer they should be. And then there's some exceptions, like when an identifier is really, really, really important in your package and prevalent, then it can be one letter, even if it's a global. And, the most prominent example for that is perhaps testing.t.
I'm not sure if you're allowed to be a teacher now.
Uh-oh. Why, Don?
Every teacher expects you to write really long, self-explanatory variable names, regardless of where you use them or when you're. At least that was my experience. I felt like every teacher wanted long variable names.
So I will comment on your change list if it uses, in a simple for loop, if the iteration variable is called index, I will, probably comment on that. Say, call it I or J or whatever.
Ian, what you got?
Okay, I don't know if this opinion is unpopular, but I feel like I write it a lot. So there's certainly people who don't seem to grasp it. And that's that the language is not perfect, but every change to the language carries a heavy cost. So when you want to come and argue for why the language should be changed, and we see that a lot. I'd say that there's probably one a day suggestion for some way to change the Go language. Don't just talk about how it makes the language better, but also spend some time to talk about how it makes the language worse. Because there's no such thing as a 100% good change to the language. I shouldn't say there's no such thing. Maybe it's out there. Maybe no one has thought of it yet. But probably it's a good bet that all the 100% good changes to the language have already been made. And so when you want to change the language, spend some time to think about how it makes things worse, as well as how it makes things better.
I think I just saw Ian drop a metaphorical mic.
We're going to go back now and think a lot about how generics makes things worse.
I think we've got plenty of people telling us that already.
I was going to say, if you haven't gotten that feedback at this point.
Well, it has been a pleasure. On behalf of my co-hosts, John and Johnny, we thank you, Ian and Robert, for taking the time to talk about the new draft proposal and generics with us.
Yeah.
My pleasure.
Been fun. Thanks for having us.
Thanks to Robert and Ian for coming back on the show, to Carmen for making it all happen, to John and Johnny for rounding out the panel, and to you for listening. If you love GoTime, I have some semi-secret news to share on a way that you can directly support the show. We are beta testing a membership that lets you get closer to the metal. We call it Changelog++, and this is the first time we're mentioning it publicly. Read all about it, help us test this program, and make the ads disappear at changelog.com/++. GoTime is brought to you by some awesome sponsors. Thanks again to Fastly, Linode, and Rollbar. And our music is provided by the one and only Breakmaster Cylinder. That's all for now. We'll talk to you again next week.
Carmen, I heard a lot of ifs from you today.
Some what?
A lot of ifs from you today.
What kind of ifs?
If this makes it into the language.
Well, you know what? Okay, so I think partly because of what I had learned with Try last year, in that there a lot of time was spent really thinking about this and trying to solve a good problem, and then a lot of the community felt like it was that's a complete. And I think, and I probably am speaking for Robert and Ian here when I say if a lot, I think that the draft proposal is explicitly meant to not seem as a fait accompli.
Yeah.
Yeah, I mean, if there's something we learned from that is that we cannot just come out with a, doesn't matter how well thought out idea and, put it out there and say, say yes or no. It's just not gonna work. There needs to be an educational process, as we had to go through it too, and that we're trying to achieve now through being more open and going, in smaller steps and getting everybody on board. And it's kind of strange because programming language evolution is really a social process. Okay, it doesn't actually matter if you have seen the light and you know exactly the perfect language, and you would just put it out there and, maybe it's 20 years ahead. Nobody would even buy it because people would not see the reasoning why you got to that point. And so you really have to get everybody along, and some people may already be where you are and some people may not, but you have to get everybody along in little steps. And that's how we eventually end up where we want to be. And we can see this with all kinds of things like garbage collection. Garbage collection was invented, in 1950 something with Lisp. The first Lisp had garbage collection, 1958, I believe. And it's taken forever before it became accepted as something that the programming language should, a mainstream programming language should have. Maybe Java was the first one that really made it mainstream. And now this is not something that is, it's still disputed or debated, I should say, but it's not as outrageous anymore. And so I think that's true for other things too.